This video is about adding RS232 to my Z80 computer, which I've got here. And this is phase one, and I've gone through testing all the components and features on this board in previous videos. But this video is about this new board. And I'll go over the actual operation of this in a circuit diagram later on in the video. First of all, I'll just discuss actually what the board consists of, and then do an actual demonstration of the RS232 communications working to my laptop computer just after I've done the description. So to get the actual baud rates for the RS232 communications, I didn't want to put another crystal oscillator on top of this on this board. I wanted to use the one which is on my computer board, which is 4 megahertz. So I've taken it through a pin on one of these connectors here, because this just plugs into the connectors over the top of my Z80 peripheral chips. So I've got a counter time, I've got a serial chip and a parallel chip. The parallel chips for parallel communications to a printer hopefully later on, but in this video I just discuss the RS232 communications for these two ports here, which come off of the UART chip, which is a Z80 SIO, but it could be a Z80 DART. They're the same kind of thing. So once I get the 4 megahertz clock up onto this board, I actually divide it down into these baud rates here. So 19200, which is a reasonable baud rate, not particularly fast by today's standards, but decent enough to actually operate this computer, and all the way down to 1200 baud. And I'll show a comparison between the two speeds when I do the demonstration. But it just plugs in here. See if I can plug it in. Just pushes down like that, so that's simple enough, and it holds in nice and tight on the board. Just like that. Let it push down to there. So in the demonstration, I will actually use my RS232 to UART connector to my laptop, which is to USB. So this plugs into my laptop, converts it to RS232, and then at the other end of there, I'll use the connector which I used when I demonstrated the Amstrad NC100 notebook computer. That just plugs into my connectors like it would do on the Amstrad computer, and that will demonstrate the RS232 communications. But I'll also unplug the UART from here, and I can plug it directly into these pins here, so I can switch between either going through RS232 if I've got an actual RS232 device, or typically if I'm communicating with my laptop, I might as well just go through the USB to UART connector, because there's no point in converting to RS232 then back from RS232 to UART. Okay, so I've got my computer here. I've got my flash turned off on my camera so that you can hopefully see the LEDs when I turn the computer on. And my computer's plugged into the serial port there. It comes through my RS232 converter and goes into my laptop through the RS232 to UART converter back up there. So when I turn the actual computer on, you can see the LEDs are flashing and stuff. Now, I haven't loaded the bootloader yet, so I'll just go through the bootloader process. And so you see on the actual terminal on my computer, it's come up with my menu. Now a lot of this stuff's still in development, so the NMI monitor, which you've seen in the previous demonstration on the video, I'll go through that and I'll show the two speeds of communication. So currently it's at 19,200 baud, so that's fairly quick. And I'll go into my monitor and I'll switch it down to the slowest speed, so you can get a comparison between the speeds of the different baud rates. And then as you can see on the menus, I haven't completed the work on this, but I'm going to get the ZX80 ROM running on here. I've already started the ZX81 ROM, and I've got some of that running, so I'll demonstrate that at the end of the demonstration as well. So you can see the ZX81 ROM running on my computer here, and then some of the other stuff will come in phase 3 potentially, but I'm not sure how much actual work that's going to be to do. So if I press F1, and there's my monitor, so it's 19,200 baud, and I can page down, and it's fairly quick to go paging down and paging up in memory to update the display. But if I change the actual jumper here, which is a bit awkward, down to 1200, which is there, and now after in the terminal I'll clear the screen, Control AC to clear the screen, and I'll go Control A P for port, and then I have to change the actual value down to previous 1200. Okay, so now I'm at 1200 on the actual screen. So if I hit enter, it will update the display, and you can see this is 1200 baud, and it's a lot slower. But in the olden days, there used to be stuff that even worked down to 300 baud, I think, which is so much slower than this. So to actually update a display, it takes that long to do. Although I've written this so that if I hit right hand cursor, it just all it has to do is update a single line. But still, even just to do that, it takes a very long time. So I'm going to put it back to the speed it was before. Okay, then Control AC to clear the screen, Control AP, and then see if I can get back up to 19200. Okay, so hit enter, and so it's a lot faster to update the screen. And I can go page down, page up. So if I go to address 0000, and then I go and tab and go to the execute mode, and then I just hit G for go, and that'll take me back to the menu. So now if I hit F3, I can go into the X81 ROM. So this boots up into the X81 ROM, and it's doing it as a terminal display, so you don't get all the characters, but I can actually enter a program in here. Rather than do that, let's put in the character set. It always runs in fast mode, so I have to do like a little pause on line 25 just so it updates the display at that point. Whoops. So now if I run this, you see it actually runs basic ZX81 programs. So if you look at other people's videos on when they've done ZX80, oh sorry, Z80 computers, they usually either get Microsoft, an early version of Microsoft Basic running, or they get Tiny Basic or something like that. Well, on my one I've got ZX81 Basic, and it runs and it works. But I still need to work on loading programs, and once I've got loading programs, I'll probably do another video demonstrating loading programs as well. And also I want to get the graphics. So phase 3, I should add some extra hardware like graphics and sound. And I'm going to be using the Texas Instrument graphics chip and the AY sound chip, and that happens to be what's in the, an MSX computer. So I might be able to emulate an MSX computer, well not emulate, but actually implement an MSX computer on this computer, but I'm not sure about that. It's probably going to be a lot of work. But now I'll go through the actual circuit diagram and show you explain exactly how this baud rate generation actually works. So this is the circuit diagram where I generate the baud rates. So I've got a connector at the top left hand corner here, and I bring up the 4 megahertz signal from my crystal on the actual computer board. I bring that into a dual 4-bit counter, so there's one of the counters, and the other counter is down at the bottom of the screen down here. And so this first counter at the top of the screen, you've got 4 megahertz going in here. And then it counts out on these as a binary counter on these pins on the right hand side. And this actually doesn't generate any actual baud rate itself, this first counter. What it does is it has these diodes on the outside, on the right hand side, and if any of these signals is low, it means that this signal on the right hand side of the diodes is going to be low. So I've got 100k pull up, so it's trying to be pulled up to a high signal. But while any one of those is low, the actual signal on the right is low. And then it's only when all of them go high, so say this one's low, this one's high, no, say this one's high, and this one's high, and the next count is going to be this one going high. So before that goes high, it's low, so it's got a low signal on the right hand side, but it's gone high, so all of these are now high, and so it gets pulled up to as a high signal, but that's on count 13. So what that's doing is it's going to divide the counters down into divide the 44 megahertz down by 13, but this also is going to be divided down by 16 in the Z80 SIO. And if you divide by 13 and divide by 13 times 16, you get 19200, which is the fastest baud rate which I produce. But there is a bit of a problem in that this is only at as a high value for a small fraction of a second, because it triggers a signal into the monostable one-shot multivibrator here, so that generates a square wave on the outside on the right hand side, and I use that to generate a bigger high part of the clock count, so that because a very short period which I get here isn't enough for the RS232 to actually recognize it as a clock pulse. So I need this monostable here to expand that clock pulse further, and that gives me my 19200 signal, which I take to my jumper pins here, so I can put a jumper over here to make it 19200 baud. But also, because I've got a second 4-bit counter down on the bottom there, what I can do is I can just take that signal and where's the signal? It comes up here. Oh yeah, the output, the 19200 output goes to the reset there, and that then resets it back, so it does a divide by 13 again. But it also goes into the clock pulse on here, so 19200 gets divided by 2, which gives me 9600, and then that gets divided by 2, gives me 4800, 2400, and the 1200 one, and I get all those for free because I have that second counter on the LS74LS393, and they just get taken to the baud rate jumpers here as well. So I can select the 19200, or I can select 9600 or 4800, and so on. So apart from that, also this board does level shifting. So I have 5 volt signals for my actual for my UART signals. So the stuff that's coming out of the Z80 SIO is all at 5 volts, and I bring that up onto the board here, so the transmit goes plus or minus 5 volts. Now I have a 10k resistor here, because I also take this signal up to the UART pins, which I can use to directly communicate through UART. So if I don't want to communicate through RS232, so like I was saying in the demonstration, if I don't want to convert to RS232 then back from RS232 down to UART, if I'm just connecting to my laptop, I can just connect my laptop on this side here, and that will, because I've got 10k limiting resistor there, it can pull, the UART can pull the signal up and down. I can just communicate via UART, and you get that for free, so why not have that? And then it's much easier to communicate just using UART if you don't have to go through the RS232 converter. But for the old equipment, if you're connecting like an old terminal or something like that, then RS232 is the way to go. Or if you're communicating with a modem and you want to communicate across telephone lines or something like that. So on the other side of here, it goes into this MAX 233. Now there's several of these MAX chips. This one happens to be one which doesn't need external components. On some of the other versions, you need external resistor and capacitors. But I was lucky because I just went for the cheapest one. I always go for the cheapest chips that I can get from my projects, and the cheapest one just turned out to be the one which doesn't need the external components, so I lucked out on that one. So the input to this is 5 volts, and the output swings between plus and minus 9 volts. But there's a slight anomaly with the RS232 in that a high signal on the input here is 5 volts, but it's minus 9 volts on the output, whereas the low signal on the input is 0 volts, but it's plus 9 volts on the output, so it inverts the signal, the RS232 does. and then it does the same for signals coming the other way. So when the communication comes in, it goes from plus or minus 9 volts on the right hand side, and it brings it down to the 5 volt to 0 volt on the left hand side, and that does everything for you. But you saw the converter that I'd made, which I convert the UART from my laptop into RS232. Well, that basically just does the same as this chip here, but I've done it in discrete logic because I didn't have any of these chips at the time. But you can, if you want to see how I built that and how that circuit works, I've done that in the previous video. But that's the basic explanation of how this serial communication RS232 to UART works on my computer.